Hello everyone, welcome back to Math 110. Last time we looked into something called one-sided limits. Sided limits. Today we'll see an example of a one-sided limit and learn about continuity and discontinuity of a function. Let's see an example of one-sided limits. Example. Consider the piecewise function and minus x plus 2 when x less than 0. Piecewise functions have different value on different intervals. In this interval, when x is greater than 0, it's x plus 1. When x is less than 0, it's minus x plus 2. Let's draw the graph of it. So when this is 0, this is our x-axis, y-axis. So when x is greater than 0, which means this side, we have x plus 1. So if this is 1, it's something like this. When x is less than 0, it's minus x plus 2, which means minus x plus 2, which means it's something like this. This is the value, this is the graph of the function of this piecewise function f of x. So what we are going to do is compute the left hand limit and the right hand limit of this function. Let's say we have to find the left hand limit first. So left hand limit. In the left hand limit, we have the definition of left hand limit was we'll go from the left side. So let's say limit x goes to 0 from the left side. We are computing the limit at x equals 0. So when I go to 0 from the left side, which means this side, let's see what happens to my function. This is equivalent to limit x goes to 0. And what is the value of our function when I'm approaching the function from the left side? When I'm approaching 0 from the left side, we get this, which is minus x plus 2. So our function is minus x plus 2. If we put 0 here, it's just 2. So let's see what happens to the right hand limit. Right hand limits are when you're going towards that value of the limit from the right hand side. It means this side. So let's see. Limit x goes to 0 from values greater than 0. What do we have here? When values are greater than 0, our function has a value of, our function is x plus 1. X plus 1. So 1. This is the left hand limit and right hand limit when x approaches 0 for this function. Notice they're different, and this is the idea we'll use when we define continuity. Okay. Let me erase this part. Okay. Continuity. We say a function is continuous if it satisfies the following three criteria. 1. Limit x goes to a from the right side of a function of the function we are considering should be the same when we go from the left side. So right hand limit, basically right hand limit equals left hand limit. The second point is limit x goes to a, f of x should be equal to, this is a, I'm sorry, f of a. I will explain this in a bit. And the third one, f of a should be defined. Let me elaborate these 2 points. I want you to think of a simple function. Let's say, not this one, this is a complicated example for these two. It could be thought of in a very simple way. Say we have a function, I think I can erase this part. Let's say we have a function, x plus 1. X plus 1. So let's say we are considering the limit x goes to 0, and f of x, what should happen to f of x? F of x should be limit x goes to 0, x plus 1, we should be 0 plus 1 and 1. The second condition tells us this limit should be the same when you plug in the value of a, when you plug in a in the function f of x. What does that mean? This thing should be equal to f of 0, 0 plus 1. This is our function x plus 1. So when you put the value a here, it should be the same when you consider the limit x goes to a. It should be the same. Also, f of a should be defined. What does that mean? It should have a certain value. Here the value of f of 0 is 1. What if we had something like 0 by 0 or infinity by infinity? Yes, they are indeterminate forms. If we have indeterminate forms, then our function isn't continuous and third criteria isn't fulfilled. The third criteria is it should have a defined value. It should have a certain value. It may be 3, 4, any number, but not indeterminate forms. Okay. This is the idea of continuity. It should follow these 3 criteria, and we are good to go. Now, let us move to discontinuity. I will teach 3 kinds of discontinuity here. One of the first one is similar to our example of left-hand limits and right-hand limits. It is let's consider the piecewise function x plus 1 when x greater than 0 minus x plus 2 when x less than 0. So the first one is, let's say, we call it jump discontinuity. Jump discontinuity. The main criteria for a function to be discontinuous is just to violate any one of the 3 criteria. If any function at any certain point does not follow any of the 3 criteria, we call that function discontinuous. So what is a jump discontinuity? A jump discontinuity is we saw our function, the graph of our function was something like this. Here, both left-hand limit and right-hand limit, they do have a value. We found out that the value of left-hand limit was 2, and right-hand limit, when x goes to 0, was 1. We saw that. They do have a value, but they are not equal, which is our first criteria. This kind of, so they are not continuous functions. So, and they are different. So they are not continuous, they are discontinuous. And when do we call it a jump discontinuity? When they pick up values like this. When you approach both the limit exists, left-hand limit and right-hand limit, but they give us two different values. That is a jump discontinuity. The second example, the second case of discontinuity is something called removable discontinuity. This is something we learned in our first class. We saw the example, our first function of the course, something like this. This is a removable discontinuity. It's like the function once is begging to get defined at this value. Why so? Because the left-hand limit, this one, the right-hand limit, say let's goes towards the same value, but they don't have, the function does not have that value, but the left-hand limit and the right-hand limit approaches a certain value. What's that certain value? F of a. This is called a removable discontinuity. Discontinuity. How can we remove it? Just follow our left-hand and right-hand limit, and the value they give, by that value we can remove this discontinuity, because they approach the same value. From the left-hand side, from this side, they approach a certain value. From this side, they approach the same value. That is a removable discontinuity. And the third one, this is our second one. And the third one is infinite discontinuity. What is this? So I'm guessing you're familiar with this function, 1 over x. What is the graph of this function? When we pick negative values, it gives us the graph is something like this. When we pick positive values, it's something like this. It goes towards infinity. As x goes to 0, our function goes towards infinity. So what do we do about our left-hand limit? Say x approaches from the left side, this side. This side, when we approach 0, from this side, we go towards negative infinity. We go towards negative infinity. When we approach 0 from the right side, we go towards positive. This side will give you positive infinity. This will give you negative infinity. When we go from the right side, we approach positive infinity. And the important thing to notice is from the right side, we go towards positive infinity. From the left side, we go towards negative infinity. And these two are completely different things. It's like having an infinite amount of money, positive infinity, and infinite amount of debt, loan, negative infinity. This is an example of infinite discontinuity.